Hey guys, here's a solution video for yesterday's problem. The first habit we need to nail down for the SATs is to read the problem carefully. It asks for A divided by B, not A and B individually. This is important because we don't need to waste unnecessary time trying to solve for each variable. In fact, you'll notice that we are only given one equation and two unknowns, or like variables again. Like I mentioned in my previous video, to find two variables, we need two equations. So it's good that we only need to find the ratio between these numbers because otherwise, again, it would be impossible. So let's just jump right into it. All right. So the first thing I like to do when working with these really complicated looking equations is to try to simplify the numbers. Prettier, smaller numbers are a lot easier to work with than large, ugly numbers, and they'll just save you a lot of headache down the road. So let's see, how can we simplify this? Well, we know, for example, that 125 is equal to 5 cubed. That means 1 over 125 is equal to 1 over 5 cubed. So how do we use this to simplify our first term? Well, we can replace 1 over 125 for 1 over 5 cubed. So we now have 1 over 5 cubed, and this is to the power of a squared plus 4ab. Now, to simplify this chunk, we can use the power of a power rule. That basically states that you have a number, let's say a to the power of m, and that is raised to another exponent n. This can be rewritten as a to the power of m times n, okay? So this over here, we can simplify further, 1 over 5 to the power of 3a squared plus 4ab, which is equal to 1 over 5 to the power of 3a squared plus 12ab. Cool. So this is the simplified version of our first term. Now let's work on this. So already the cube root of 625, that looks pretty gnarly to me. But we can rewrite this actually as 625 to the power of 1/3. Now we can rewrite the second expression, right, to say that the original cube root of 625 to the power of 3a squared minus 10ab is equal to 625 to the power of 1/3, which is then to the power of 3a squared minus 10ab. And like we saw earlier over here, we can simplify this further to say 625 to the power of 1/3 times 3a squared minus 10ab, which is equal to 625 to the power of a squared minus 10ab over 3. Cool. So now we have our numbers somewhat simplified. So combining what we had earlier, we can say 1 over 5 to the power of 3a squared plus 12ab is equal to 625 to the power of a squared minus 10ab over 3, right? You see how this is just a lot cleaner to work with than the original equation? I mean, it's not like the best, but it is, we're getting there, you know? So let's see, how can we improve from here? Well, we can use actually the negative exponent property, which says that a to the power of, let's say, negative x is actually equal to 1 over a to the power of x, right? So that means, you know, we can switch 1 over 5 to 5, right? 5, and just have its exponent be a negative value. So negative times 3a squared plus 12ab equals 625 to the power of a squared minus 10ab over 3. Okay? Now we also know that 625 is equal to 5 to the power of 4. All right? If you didn't know this,
Now you know. No. If you don't know, now you know.
You can just plug it into your calculator and, you know, use the logarithm to find out. Anyways, we can now further simplify this to say 5 to the power of 4, right, to the power of a squared minus 10ab over 3, which is equal to 5 to the power of 4 times a squared minus 10ab over 3, right? which is equal to 5 to the power of 4a squared minus 40ab over 3. So finally, bring this down over here, we have 5 to the power of negative 3a squared plus 12ab is equal to 5 to the power of 4a squared minus 40ab over 3. Since the bases are now the same, we can just compare the two exponents over here, right? Because these should be of equal value. It's like saying, 3 squared is equal to 3 squared. These numbers need to be the same. So let's just set these two terms to be the same, and we should be closer on our way to find the solution. All right, simplifying here. And then, cancel it out over here. Negative 12ab is equal to 7a squared minus 40ab over 3. Move 40ab over on the other side. So 40ab over 3 minus 12ab is equal to 7a squared. 40ab minus 3 times 12 is 36. So 36ab over 3 is equal to 7a squared. Using our cross multiplication rule, we have 21a squared is equal to 40ab minus 36ab, which is equal to 4ab. So 21a squared is equal to 4ab. 21a is equal to 4b. And now the original problem, we wanted to find the value of a over b. So let's do that. Divide, let's see, both sides by b. We get 21a over b is equal to 4. And then finally, dividing both sides by 21, we get a over b is equal to 4 over 21. So our answer here is a. Let's review the process we just went through. I know it's a lot. We first wanted to simplify our values so that they're easier to work with, which is why we converted 1 over 125 to 1 over 5. Simplified this monstrosity to something a little bit more manageable over here. Okay? Then we want to set the bases equal to each other, since that's how we know that the exponents are the same, right? Again, 3 squared is equal to 3 squared. If the bases are equal, the exponents are also equal. So then we transition to just set the exponents equal to each other, right? And with that, it becomes just a simpler algebraic expression. This is a pretty tough question, so don't be discouraged if you didn't get it at first, but it is important to understand what I just went through and be able to follow the. If you think this video was helpful, follow, like, comment, share to your friends, and just don't be a